Well, good morning. This is it's 8:42 now on Thursday morning, the 16th of July, 2020. It's supposed to be differential equations class, and I'm on Zoom waiting for anyone to show up. I've been here. My Zoom was very, very slow. It took at least 2 or 3 minutes for it to come up this morning. So then when I got into class, nobody was here. Nobody was waiting, so I went to Blackboard to see if there were any messages there. There weren't. I sent a message in Blackboard saying, hey, are y'all having problems with Zoom? Are you trying to get in and I can't see you? You can't see me. What is the issue? I still have received no messages on Blackboard, and I've received nothing, no one trying to get in on Zoom. So I'm going to go on and start the class. We can't afford not to have class today. I'm going to check one more time just to see if anyone's responded on Blackboard. Not a soul. Okay, so let's go back to Zoom. Go back to the PDF. Okay, so I guess I'll just start teaching. I hate to teach with no one here, especially if there could be somebody out there waiting. And there is no one waiting on this channel. Now, this happened with another class. I was in class. They were trying to get in class, but I couldn't see them, and they were told I was in another class. And Zoom just seems to be reaching its capacity and just fouling up like crazy. So I'm afraid that's what's happening now, but at least before they started messaging each other on Blackboard, and that's where I finally found them. That's why I did it with this class, just to see if y'all were beginning to message on Blackboard. You see, if you were to do chats here, I wouldn't see them because we're not on the same one. Okay, so if you're there, I don't even know if you're there. I'm going to check Blackboard one more time. Nobody has responded. So go back to here. So I guess I'll go on and start teaching. Okay. I can't think of what else to do. If I had any clue that anyone was out there, I could shut down everything and bring it back up. I had to do that in a class yesterday, but that was a different issue. I can't remember what the issue was. Zoom has had so many issues lately. In fact, I think I'll try that first. I'm going to try Blackboard one more time. It's nobody there. So I'm going to shut down everything and bring it back up. Oh no, I remember. Sorry. That wasn't what happened yesterday. Last time, yesterday, I couldn't even get Zoom to come up. That's what the problem was. So I had to shut everything down and try again, and then there were people waiting. They were having trouble getting in Zoom too, so that's what made me think that. But this time, Zoom finally came up, and I'm in the right class. I've checked that out. I've made sure that the invite went out. It did. Everything checks, except there's no students here. So just to keep you from losing total instruction today, let's go on and do pick up where we left off last time. I hate this talking to myself, but anyway, we're on in chapter 4, higher order differential equations, in section 4.3, homogeneous linear equations with constant coefficients, and we're on example 4. We've done the others. Let me, one thing here, get my picture out of the way as much as I can. That's, I think, pretty good. Okay, and here's example 4. It's a fourth order differential equation. They've written it in Leibniz notation, so it looks a little different, but it's still the same. d4y by dx, the fourth derivative of y with respect to x 4 times, plus 2 times the second derivative of y with respect to x twice, plus y is equal to 0. Okay, there's the problem. I'm going to go to the whiteboard. I'll also check and see if any more students are here. I don't see any. I'll check and see if anyone's in Blackboard. No, they're not. So go back to, this time I'll go to the whiteboard. Okay. Sorry folks, I don't know what's going on. It may be everybody's running late today. I know I was running a little late because I had to take my wife's car to the shop, and then she had to pick me up, and she was held up, so there were issues. Okay, I'm going to move, well, let's first move this taskbar. You can't see it, but I can. It gets in my way over here as far as I can out of the way, and then I'll move the whiteboard as far as I can this way to get the optimum amount of white space. Okay, so here's example 4. Okay, d4y by dx to the 4th plus 2 d2y dx squared plus y is equal to 0. Now, even though that's 4th order, it's still a linear homogeneous, that's the equals 0 out here at the end. Linear because none of the derivatives are multiplied by any other power of y. Oops, if I had written the problem right, that's plus y, okay, is equal to 0. Okay, none of the other derivatives of y itself raised to any other power or multiplied by another derivative of y or y itself. So this is a linear linear 4th order homogeneous differential equation with constant coefficients. The first coefficient, of course, is 1, 2, and 1. Okay, so our assumption here is when you have that situation, let y equal e to the mx. That will work when you have constant coefficients. Okay, so what that produces is a 4th order auxiliary equation. M to the 4th power plus 2 m squared plus 1 is equal to 0. Now, you may note that is a perfect square trinomial. Perfect square of m squared plus 1 squared. Okay, now if that's the case, and you should have noted this in the very beginning, if that's the case, there is no real solution to either of those equations. Okay, it just won't happen. Any real number m raised to the 4th power is going to be positive. Add any real number m raised to the 2nd power is going to be positive. Add 1 to that, hey, you got a number 1 or greater. Okay, so this can't possibly equal 0. Okay, so what that means, you have the only solution is m is equal to I think plus or minus I. Yeah. Because m squared plus 1 is equal to 0. M squared is equal to 1. No, it's minus 1. M would equal plus or minus I. So there's your possible solution, plus or minus I. Complex conjugates of each other. Okay, but the trouble is, you got a 4th degree, so these are both going to be repeated roots. Okay, plus or minus I is repeated twice because of that 2nd square, the square on the outside. So if you recall what our case 3 is for those, your solution would be y is equal to, remember you had e to the mx, where m was the real part of this. The real part is 0. So e to the 0 is 1. Okay? Times c1 cosine. Then the imaginary part is the real part of the imaginary part. The real coefficient, the b, is plus or minus 1. So you have cosine x plus c2, c2 sine x. Okay? But that's just two arbitrary coefficients. And because this is repeated root, what we do is then add to this, just like we did before, x times c3 cosine x plus x times c4 sine x. Now, wrote that rather poorly. Probably should have put the c3 and the c4 in front. c3x cosine x plus c4x sine x. There is your four arbitrary coefficients that are required for a fourth order differential equation, and a fourth degree polynomial too. There are the four possible solutions for that differential equation. Let's see what they got. Also, y is equal to c1 cosine x plus c2 sine x plus, and they put the c3 in front, c3 x cosine x plus c4 x sine x. Same principle holds if you have repeated roots, which we did, then just put another power of x in there. Okay? Now, and for some reason they backtrack here and go back to what the m's were when we were doing the original things, which was your e to the a plus I beta x and e, and then x e to, and I like that. I don't know why they went back to that. Just go back to what we were doing before and do this. So then you would have e to the alpha x, if you had an alpha other than 0. If you had a number there, a real part for that imaginary, that complex number, then it would be e to the alpha x times, and then you would include that in every term, or pull it out and factor it out of every term, and then you'd have your cosine beta x, sine beta x, and then if you had another degree, another repeated root, that'd be x cosine x and x sine x. If you had yet 3 repeated roots, x squared cosine x, x squared sine beta x, and keep on going until you have you've exhausted and you've got as many arbitrary coefficients as you need. In example 4, the k was 2, so we stopped at 1x. Okay, c1. Okay. Now, remember that just because they do a flashback here, and let's take you back to the flashback. So let's go back to, actually before I go back there, I want to check and see if anyone sent a message. Not a single message yet. You can't see that, but I can. So now I'll go back to a new share here, and that's the book. Okay, I'm going to set my pad down for just a moment while I scroll down through the book here. This is what I was just reading. There was our solution, just like we got, c1 cosine x plus c2 sine x plus c3 x cosine x plus c4 x cosine x, x sine x. The reason we had that, we had repeated roots. the way they said it, M1 and M3 were I, and M2 and M4 was minus I. Okay, however you want to say that. Because you had a repeated root, you put down the 1 for the first, C1 cosine x, C cosine x, and then for the first repeated root, you just multiply that by x, new coefficients, C3 x cosine x plus C4 x sine x. If that had 3 repeated roots, then do another one. C5 x squared cosine x plus C6 x squared sine x, and keep going. And that's what their next thing that I was looking at the book and should have been showing you here there. I don't know why they went back to this again. We've already dealt with that using Euler's formula and all that kind of stuff to get this ugly looking form with eyes all over in it into your form with no eyes, no imaginary parts, and now everything, if you had an alpha there, we had an alpha of 0, so e to the 0 is 1, so we didn't have to have this. But if you had an alpha anything other than 0, then you have an e to the alpha x in front of every term. So go on and factor it out of every one of them. And then you have a cosine beta x plus sine beta x. Then if you had a repeated root, x cosine beta x plus x sine beta x. If you had another repeated root, still nobody coming in. I don't know where everybody is today. Okay, x squared all the way up to xk minus 1. Our example was k was equal to 2, so k minus 1 was 1, so we stopped right there with the x sine x. Okay, now here's what I was starting to read, and I realized, wait a minute, we have this on the book, so let's do it here. Of course, the most difficult aspect in solving constant coefficient differential equation is not the calculus or the differential equation part, is finding those roots of the auxiliary equation of degree greater than 2. Something we try is to test the auxiliary equation for rational roots. Okay, I don't know if you remember this. We used to call this x, but now we're calling it m. Okay, your possible solutions for that polynomial equation in m would be m is equal to some ratio of p over q, where that's a rational root expressed in lowest terms of the polynomial equation, and however many coefficients you had, these, remember, are all constants. They're not functions of x. A sub n, m to the n plus a sub n minus 1 times m to the m minus 1, all the way down to a 3m cubed plus a sub 2m squared plus a sub 1m plus a sub 0 equals 0. That's what your auxiliary equation looks like, a polynomial with constant coefficients. Okay, now if you have a rational root, and by the way, all those coefficients now need to be integers. They can't be fractions, they can't be decimals, they can't be irrational numbers. They've got to be integers. Positive or negative is fine. All but a sub n could even be a 0. That's fine. But they have to be integers. Well, then your p then in this ratio is any factor of a sub 0, the constant term, and the q is any factor of your a sub n, the leading term. And remember, a sub n cannot be 0, so therefore you could divide by the q, because that can't be 0. So here's one example that we'll use using that. This is a third order differential equation, and as soon as we do something with it, you'll see what its potential problems are. Okay, so I'm going to go back. Every time I change screens, I'm going to check and see if anyone sent a message. Nobody has sent a message yet. Okay, so let's go back to this time the whiteboard. All right, I'm going to clear this since nobody's here. I'll clear this out of the way. I hope you got it, but it's being recorded. So here's example 5. Going back to the prime notation, which is a lot easier to write. 3 y, that's a 3. I don't know why they put that thing. The pen does strange things. Triple prime. See, like it doesn't write there. Okay, plus 5y double prime plus 10y prime minus 4y is equal to 0. Okay, a linear, third order, homogeneous differential equation with constant coefficients, and this time the constants are all integers. Most of the time they have been, but this time for sure. Okay, so our assumption here, as always, will be that your y will be some e to the mx. That's where we're going to start. And that produces the auxiliary equation of 3m cubed plus 5m squared plus 10m minus 4 is equal to 0. That's your auxiliary equation. Okay. Now, I think I've written everything down I need to. I'll get the book out of my lap. Okay. Just use my Wacom here. Okay. Now, if you know how to factor cubic equations, knock yourself out. Okay. One possibility would be potentially factoring by grouping, because that's a 4-term polynomial equation. But if you'll notice here, if you group the first 2 terms together, these two, you only common factor would be m squared. You have 3m plus 5. Group these together, and possible factor would be 2, and you have 5m minus 2. Nothing there to continue factoring. So factoring by grouping does not work. That's one technique you do have for any time you have an even number of terms in a polynomial. Try factoring by grouping. Didn't work here, move on to the next step. Well, this is because these are constant coefficients and they're all integers. There are a couple more tricks, and let me go on and mention the tricks. I don't know if you remember from pre-calculus that Descartes' rule of signs says you have only one positive real root, because you only have one change of signs here in that polynomial. So we're only looking for, I'm going to write that down, one positive, that stands for positive, real root. This is an aggravating little board. One positive real root. Okay? Now, Descartes' rule of signs says if you replace the m with a minus m, that would make this a minus, that keeps that a plus, that makes that a minus, and keeps that a minus. So then you'd have a minus plus minus, so you would have 2 or 0 negative real roots. This pen is just really bizarre. Okay, so just to keep that in mind. Okay, now let's do our rational zero test. Okay, rational zeros test said your solutions m, I can get it to right here, m is going to be sum p over q, where p is any possible factorization of the constant term. Well, that's going to be a plus or minus 1, a plus or minus 2, I can't get it to right, or a plus or minus 4. I'm going to move my box out of the way here. That's pretty ugly. Plus or minus 4. All that over all the possible factorization of the leading term, leading coefficient, and that's a 3. So its only factorization is plus or minus 1 and plus or minus 3. Okay. Now, if we list these out then, the possible m values, now you know you can't have more than 3 because it's a third degree polynomial, but it could be plus or minus 1, plus or minus 2, and plus or minus 4. That's when you use the denominator 1, or plus or minus 1/3, plus or minus 2/3, or plus or minus 4/3. Okay, that's if you use the denominator of 3. Okay, a lot of times, not this time, but a lot of times you may repeat, like if that was a 2/4 rather than a 2/3, well, that's 1/2. You don't, I'm sorry, let's say 4/2. That last one, if there had been a plus or minus 4/2, you don't have to repeat because you already have plus or minus 2 there. This one, you got to list them all. Well, we'll see. Descartes' rule of sign says stop if you find one positive real root. Don't look for any more. Now, the first and the easiest one always to test is 1. Because if your m was equal to 1, this would be 3 plus 5 plus 10 minus 4. Obviously, that's not going to be 0. 18 minus 4 is not 0. So plus 1 is out. Okay? Don't even bother. Now, how do you check the others? The easiest way, if you learned this back in pre-calculus algebra, is to use synthetic division. So the next easiest would be minus 1. So let's just do synthetic division on this. We could have done that with plus 1, but guess what? It's so easy just to plug it in. All right, now synthetic division, you put your coefficients here. 3, 5, 10, and minus 4. Now, I always do this. Count the number of numbers you got there. 1, 2, 3, 4. Always has to be one more than your degree. It is. That means we have no missing terms. If we had a missing term, you've got to put a 0 in that place. Now we don't, so we're fine. So skip a line, draw a line. That's my little rule. Bring down the first one, 3. Multiply, -3. Add 2. Multiply, -2. Add 8. Multiply, -8. Nowhere close. You're not going to get a 0 here. That's what you required to get a 0 here in order for that to be a factor. So -1 doesn't work, +1 didn't work. Both of these are out of there. Not going to consider those. So I'm going to just come up here to my handy dandy little eraser, and if I can get it to erase the -1 and erase these numbers and erase those numbers. The rest of them are going to stay the same. Go back, pick up my pen. I know if you're doing this on paper, especially if you're using ink, you're in serious trouble. Pencil, I just start over. But I don't have room, so let's do a 2 then. 2 times 3 is 6. 6 and 5 are 11. 2 times 11 is 22. That would be 32. No way, no way, no way. So +2 is not going to work. So let's try a -2. Well, I'm going to have to find my eraser again. Okay, and erase these numbers and these numbers. The rest stay the same. Okay. Okay. -2 times 3 will be -6. That gives you a -1. -2 times -1 is +2. That gives you a 12. No way that's going to work either. Negative 2's out, so plus or minus 2 are both out of there. Let's go for 4. Okay. Yuck. Okay. So, all right. Let's try 4. Okay. 4 on the outside. 12. 17. It ain't gonna work. Okay, your number's just getting way too big and not enough to ever come down. 4 is not gonna work. Let's try a minus 4. This seems really slow, doesn't it? Okay, there's the eraser. Goodness gracious, this thing is not moving well at all. There we go. So let's try a minus 4. Okay. That would be a negative 12. That would be a negative 7. That would be a 28. No way. No way that's going to work either. Sorry about that. Nah, I'm afraid we're going to have to deal with the fractions. I'll try to avoid the fractions at all costs, but not going to work here. It looks like we're going to need a fraction. Okay? I meant to point something else out to you, I forgot to, but let's do it. Let's try the 1/3 first. 1/3 times 3 is 1. 5 and 1 is 6. 1/3 times 6 is 2. That would be 12. 1/3 times 12 is 4. And that gives you a 0. Okay. Ding, 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 we have a winner. M is equal to 1/3. Now, there's a couple things. Here's what I forgot to say before. And if I had said it before, I would have saved ourselves a lot of grief. Okay? Number 1, if we had carried out that +1, which we didn't because we knew it wasn't going to work, but then when we did the +2, if I would have carried that out, I would have found that all the numbers down here were positive. Once you find them all positive with a positive number up here, you know you passed the maximum. Okay, that's called the upper bound test. There's no more beyond that. In fact, looking at this right here, all these are positive. So don't even try anything yet, because 1/3 is the only positive number. And remember Descartes' rule of sign? You only have one positive real root. There it is. Now you could have 2 negative real roots, or you could have none, which means you would have complex roots. But stop here. Once you get 3 numbers here, that represents a quadratic. That would be 3x² plus 6x plus 12 is equal to 0. Now, if that's the quadratic, first thing I'm going to do is factor out of 3. 3 times x² plus 2x plus 4 is equal to 0. Okay? Now, I know 3 is never equal to 0, so I'm going to divide it away. And I'll look at this and say, is there any way to factor this? And the answer is no. So we're going to have to go to the good old quadratic formula. Good old quadratic formula. I'm sorry. I just did what I'm used to. Got so much into the mode of pre-calculus algebra, I went back to x's. Remember, these are m's, not x's. So that would have been an m². That would have been an m. This would have been an m². That would have been an m. So our solutions are m is equal to minus b, that's a minus 2, plus or minus the square root of b squared, which would be 4, minus 4 times a, which is 1, times 4, which is 4 times 4 is 16, all over 2a, which is just 2. Okay, this will be a minus 2 plus or minus the square root of a negative 12 over 2, which is minus 2 plus or minus, factor out the negative 1, that gives you an I, factor out a 4, that gives you a 2, square root of 4 is 2, and you're left with a root 3, if I can get my pens right, over 2. But notice every one of these terms has a 2 in it, so we can divide out our 2. So our m's are now minus 1 plus or minus I root 3. Now, I think this book does it this way. A lot of books like to write root 3 times I. I don't like writing it that way because sometimes I'll think that I is under the radical when it's not, or out from under the radical when it is. So I always put I in front to make sure I know that's not under the radical. All right, well, there's your A right here. I mean, your alpha right here is your minus 1. If I could get the pen to come down, yeah. So this is your alpha, the minus 1, and this is your beta, the root 3. So now we can write down our solution. Okay, our solution is from the first one, y is equal to c1 e to the x over 3 plus e to the minus 1 with, minus x, okay, minus 1x, times c2 cosine root 3x plus c3 sine of root 3x. A lot of times I like to say x root 3, same reason, so I won't think that's in there. And I got to get my pen back. There we go. Close that out. Okay. So that is my solution. 3 arbitrary coefficients for a third order differential equation. You had one real part. You had no negative real roots, but you did have 2 complex roots, and that produced the e to the alpha x, and then a c1 or c2 cosine root 3x and a c3 sine root 3x. Okay, let me, before I erase this, make sure. Okay, y is equal to c1 x to the e to the x over 3 plus e to the minus x times c2 cosine root 3x plus c3 sine root 3x. Got it. Okay, now before I do anything else, I'm going to go back and see if anyone's responded with a message. Nobody. So let's go back to the book. Okay, and there's our solution. The same thing we got. Y is equal to c1 x e to the x over 3 plus c e to the minus x, that came from the alpha here of minus 1, times c2 cosine root 3x, that's from your beta here, plus c3 sine root 3x from your beta there too. Okay. Now, next little blurb in the book certainly is true. Can't get it to advance. There we go. Use of computers finding roots or approximation of roots of auxiliary equations is a routine problem with an appropriate calculator or computer software. And they talk about Mathematica and Maple. If you have access to that, by all means use it. Okay? Otherwise, you're stuck with rational zeros test, Descartes' rule of signs, the upper bound test, the lower bound test, those kind of things. I didn't tell you the lower bound test, but let me explain that to you. If you're doing your synthetic division with a negative number on the outside, and you wind up with alternating signs on the bottom line, you might say, once you get those alternating signs, don't go any more negative than that negative that you had there. It's not going to work. You won't have any. Okay. So, move on down. Classic test, blah, blah, blah. They give you this. It is not reasonable to expect students in this course to have computing skill and equipment necessary for efficient solving of equations such as fractional forms there. That's a constant coefficient, but guess what? You're sure not going to be able to use the rational zeros test because that requires integer coefficients. So for something like that, it's almost hang it up. Okay? You go to numerical methods. Okay? Although it's debatable whether computing skills have improved in the intervening years, certainly has the technology has. So if you have access to a computer algebra system such as Mathematica or Maple or any of the others, then you can probably come up with an answer such as this. But still, that's going to be an approximate answer. I guarantee you that's a round off number. That's a round off number. Now you've rounded it to 6 digits. Okay, that's pretty precise, but it's still not exact. Okay, this is a round off number, that is, and that is. So sure enough, looks like they just stopped you at 6 digits of precision, which is close enough by just about every count available. Excuse me just a second. My throat is getting dry very early in the day here. Hold on. It's been an unusual morning. I think I mentioned I had to take my wife's car to the shop this morning, and she had to pick me up and bring me back. And then this afternoon I'm going to be out of pocket for just a short time when I take her back to pick up her car. But I don't have to stay. I'll just take her to the dealership. As soon as I know it's okay, then I'll be coming back. So I will be out of pocket. I have my phone with me, but that'll be hopefully sometime between 1:15 and 3 o'clock. I've got I got class going to 1:15, advising starting at 3. If it's not ready by then, I have another little bit of time between 4 and 5. My advising goes until 4, and I have another class starting at 5. So it's a broken up day. The reason I started this, I did not have my usual morning. Usually I drink a few more liquids and things like that in the morning just to rehydrate. This morning was sort of rushed and not have a chance to do my normal routine. So let's move on down to, that is it. And the good news here, this section doesn't even have one of those remark sections that are sort of a pain in the neck. Here are the homework exercises for 4.3. I've given some of these before. Here's the rest. Any of the odds, 1 through 13, that you have answers in the book, certainly open game. Any of the odds 15 to 27 that are in back of the book, those are open. Any of the odds 29 to 35. Let's see if I can get those on the screen. There's 29 through 35. And then any of the odds 37, either 37 or 49. 41, if it's in the back of the book. And 43, any of the odds 43. That's on the bottom of this, no, 43, 45, I think 47 is on the top of the next page. Can't show a full page here and have it legible. But any one or more that are in the back of the book of 43 to 47. plenty in this section, aren't there? And any of the odds 49 through 57, okay, that are in the back of the book. Now, if any of the discussion problems, odd number discussion problems, have answers in the back of the book, probably worth looking at. You're not required to do those by any means. That's homework is completely up to you, but go with that. Now, those are the rest of the discussion problems. All right, now we're getting ready to start 4.4. Before we do, I want to check one more time and see if I've had any response at all. None under Blackboard messages. I don't know where people are this morning. This is, I mean, almost to the point of being scary. Zoom has been screwing up lately, and they may be screwed up today. I'm in the class, and maybe I can't see the students in the class. It may be the students are trying to get in the class, and they're being told I'm in another class. That happened before. I can't imagine why it should be happening now. The last time I had just gotten out of a class that ended at 2:30 when I was starting a second class at 2:30, and it could be that Zoom somehow got me in the other class, even though it said I was in the right class. But this one, I wasn't in any class this morning before 8:30, so it makes no sense. Now, this is a small class. I know that Corbin and Cole were not here last time. I know Melissa wasn't feeling well last time, so she may not be here. Ricky, I know, has other responsibilities. Billy and Dawson are here most of the time, but not all the time, so it could be that just nobody showed today, which is your prerogative, but I hope you go to YouTube videos to see today's class. So let's pick up with 4.4. Okay, now what the deal is here, we have you're not always blessed with having linear differential equations with constant coefficients that are homogeneous, okay? That's not usually the case. Usually you do have something on the other side besides a zero. We know what to do if there's a zero there. What if there's not a zero there? What if there's a g of x there, like you see right here? Okay? Well, here's the technique. You first find what they now call the complementary solution, y sub c. What is y sub c? That's when you set the z of x equal to 0. And now you make it homogeneous linear differential equations with constant coefficient. And you know how to do that. We just did it. That was 4.3. Okay? You do what it takes to find that the solution's there. Except that's not your general solution. That's now the complementary solution. Then you turn around and find any particular solution y sub p that will work for the g of x. So that's what we're going to be doing in this section. How do we find that the y sub p's? We know how to find the y sub c's. We're going to do more of them. But how do you find the y sub p's? Now, there's two ways to do this. Okay? And what it is, they call this undetermined coefficients. Okay? Basically, as you'll see when we get into this, you'll see that there's certain forms that this g of x could take on, but that's just a form. That could be multiplied by some sort of coefficient. Now, these are not arbitrary coefficients. These are fixed coefficients. So they're undetermined. And that's why they call them undetermined coefficients. Now, the technique we're going to do is called the superposition approach, because it's very similar to other things we've done in superposition. at the bottom of the page, you'll see Note to Instructor, the method of undetermined coefficients developed from the viewpoint of superposition principle of the non-homogeneous equations. But section 4.5, an entirely different approach is presented, one utilizing the concept of differential annihilator operators. And it says for me to take my pick. So I taught a few classes with this one, and then one term, and always before this, I used to say, which method do you want to do? And one class had a very few people in it, probably smaller than this class, and I think only one person was there that day. He said, let's do the annihilator, that sounds like fun. So we did the annihilator, and it was fine. It was fine. It really, in many ways, is not that much different from this one, but there was a bit more involved. Okay, had a little bit more explaining had to do, and I determined after that, it looked like to me, because we're used to superposition already, it seemed like this was the way to go. It seemed like this was a little easier for me to teach and a little easier for the instructors to the students to grasp. So I'm going with that. If any of you have an objection, speak your mind or forever hold your peace. Oh, nobody's here, so we'll go with my way. Okay, so here's what we're going to do. We know how to find the general solution of the associated homogeneous problem. That's called the complementary solution. So we're going to hold that. We know how to do that. So the method of undetermined coefficients, the first of two ways, we'll consider obtaining the particular solution y sub p for the non-homogeneous linear equation, differential equation. It's called the method of undetermined coefficients. The underlying idea behind this method is a conjecture about the form that y sub p would have. Now what that means is an educated guess. It's your best guess of what you think might the answer be. Okay? Now, what you have to keep in mind when you're doing this, when you're taking all these derivatives, okay, you have to keep in mind what kind of forms are these producing, and you have to allow for any of those forms to show up in your y sub p. Okay, so the first of these, let's say the coefficients, and this is true, a sub i's are all constants. Okay, the g of x is just a constant k or a polynomial function or an exponential function, e to the alpha x, or a sine or cosine function, sine beta x or cosine beta x, okay? Or, here's a finite sum and product of those functions, constants, polynomials, exponentials, sines and cosines, okay? So we're going to limit ourselves to those. Okay. Now, this is the one that's undetermined coefficients. Oh, here comes Dawson. That is so good to see. My word, I was beginning to be worried. I was worried. Okay. Dawson, I don't know if you're here yet, and you may find this hard to believe, but you're the first and only student to show up. Can you hear me yet? Okay, did you have difficulty getting in, or were you just running a little late this morning? Okay. Zoom has been screwing up fairly badly for the last couple of weeks. I did have a class one day that was just like this one. I went in the class and nobody was there. I didn't know what to do because usually people were waiting. Nobody was waiting. So I decided, let's see, for some reason in that class, I decided not to start teaching because it was a class with, not an upper level class like this one. But it was such a big class. There was just, and there were always people waiting. I just didn't think it was possible that no one was there. So I waited for people to show up. They never did. I went and checked Blackboard and finally saw they had been sending messages to each other. They were being told I was in another class. I was in the right class, but I couldn't see them coming in. They were told I was in another class. So it just screwed up miserably. We lost probably half an hour or more getting everything done. I was afraid that was happening here, and I went back and forth, but I just decided to circumvent some things. So I have my, I don't know if you probably can't see it, but I have Blackboard, Blackboard on this button down here. I don't know if you can see it on this button here and under messages. So I was just checking to see every time I change screen, I go down and check and see if students were out there saying, where is he? Where's the class? Have I got the right number? I was seeing none of that. When you showed up, I was so happy that at least I don't have people waiting that I can't tell are waiting. So glad you're here. You've never been so appreciated in your life, have you? All right. Now from yesterday or Tuesday's class, we were in 4.3, and this morning I went on and finished 4.3 and are now starting 4.4. And if you'll note the note at the bottom of the page on 4.4, you see it right there to instructor, but you can read it too. It says you can either use 4.4 or 4.5, whichever. I've taught from both, and it seemed like students picked up the 4.4 more easily than they did 4.5. They both have some challenges, but it seems like they're sort of more used to doing superposition than they were annihilation. So I did teach it one time with the annihilative method. The student who was there that day when we got to this point, it was only 3 people in the class, only 1 showed up that day, kind of like today. And I said, what you want to do? He said, let's do annihilator. That sounds like fun. So we did annihilator, and it wasn't as much fun as this one, so I went back to superposition. Okay, and it may be just because I've taught it so many times. Now, I've just finished saying this. The difference in 4.3 and 4.4, 4.3 was strictly homogeneous equations. Linear, nth order, homogeneous, differential equations. Homogeneous meaning they're equal 0. Okay? With constant coefficients, that means you can use the assumption y is equal to e to the mx. Okay. What we're doing in this section is now putting a g of x out there, not a 0. Well, we start the same way. We first assume the g of x is equal to 0 and come up with what we call the complementary solution, okay, of the homogeneous part. That's what that's called. That's where all the arbitrary coefficients go in the complementary part. Then what you do is start figuring out what kind of functions will produce a g of x on the right hand side. And what they were just saying here, we're going to start with g of x being a constant k, polynomial, an exponential function e to the alpha x, sine or cosine function, sine beta x or cosine beta x, or, and this is the fun part, finite, meaning not infinite, but finite sums and products of any of those functions, constants, polynomials, exponentials, sines, and cosines. Now, obviously, a constant function is also a polynomial function. But since it's probably not the first thing that comes to mind when you think polynomial, we're going to say constant functions as well. There's a little bit of redundancy there, and certainly it's redundant when you say sums and products of a constant and a polynomial. That just now the constant becomes a polynomial, so it's no longer so. But with that in mind, let's move on. The following functions are examples of the types of those, what they call the input functions, g of x, that, and this was from a remark at the end of one of the previous sections, these are functions. G of x equal 10. Well, obviously that's a constant, okay? So, g of x equal x squared plus minus 5x. That's a polynomial function. g of x is equal to 15x minus 6 plus 8x to the minus e to the minus x. Well, that's a sum of a polynomial and an exponential function. And remember, sums or finite sums or products can work. G of x should be sine 3x minus 5x cosine 2x. Well, that's a sum of a sine and a cosine, but that cosine function is a product of a polynomial and a cosine. That's still legitimate. Here we have a product of a polynomial function, an exponential function, and a sine or cosine function with a sum of a polynomial function times an exponential function. So there's all kinds of convoluted combinations you can have, but they have to be of those types: constants, polynomials, exponentials, sine or cosine. Okay? Now, that is another way to express that. G of x is a linear combination of functions of the type a sub x, a sub n, x to the n plus a sub n minus 1. That's a polynomial function. A linear combination of polynomial functions, exponential functions, p of x, times an exponential function, p of x, a polynomial function, times an exponential times a sine or cosine, and p of x times an exponential times a cosine function. So any one of those and any linear combination of any of those. Okay. Now, your n is a non-negative integer. For it to be a polynomial, you cannot be raising the n to a fractional power. You can't be raising it to a negative power. You can't be raising it to a decimal power. It has to be a non-negative integer. The alpha here and the betas here, those are all real numbers. No complex numbers are sneaking their way in here. Okay? Not for your g of x. Now, the method of undetermined coefficient is not applicable to these. A log x, even though that's the inverse of an exponential, no, you will not get that to work. A reciprocal function, no, it will not work. Or any rational function that has a variable in the denominator, no, g of x will not work. This technique, undetermined coefficients, will not work there. Tangent, yeah, sine and cosine, yes. Tangent, no. Inverse sine, nope, not that either. Okay, so it has to be one of those four kinds: polynomials, exponentials, sine or cosine. And you can throw in constants if you want to. Now, the set of functions, let me see if I can scoot this up some. You came in for all the blah, blah, blah reading. You missed all the action. Go back and watch the YouTube video once it gets out there. And that will be sometime later this afternoon or evening. I told the class with nobody here earlier, I am going to be out of pocket for a brief time. This morning, just shortly after 7, I left to take my wife's car to the shop. Someone hit her right rear door handle in the parking lot and broke it, so no one can use that door anymore. And the dealership said it was a fairly simple fix, so but they had to order the part. So it came in yesterday, I think it was, so I had to take the car to the shop this morning, and she came and picked me up and brought me back home. So my morning has been sort of convoluted already this morning, but that means sometime this afternoon they'll be calling and telling her her car's ready. Well, I have one window of opportunity between 1:15 and 3 o'clock. My linear algebra class ends at 1:15. 3 o'clock I have 2 back-to-back 30-minute advising sessions already scheduled. So I've got to be here from 3 to 4. And then from 4 to 5, I have another small window of opportunity from 4 to 5, because at 5 o'clock I have a class starting. Okay, so, and then it goes till 6:30, and the dealership's only open till 6. So I will be gone for some short period of time this afternoon. It could be that's the time when I normally would be putting your class on the playlist, and so you could access it through Blackboard. So I may be late doing that today, depending on when they call and when it finally gets ready. So you won't be able to see it immediately, but when you are able to see it, you can pick up the things we did. Okay, let's see. I skipped some of the verbiage here. Freudian, I think. Okay, set of functions that consist of constants, polynomials, exponentials, e to the x, and sines, cosines have a remarkable property that their derivatives of their sums and products are again sums and products of constants, polynomials, exponentials, sines, and cosines. That's why logs won't work. Derivative of a log is an exponential. Is a rational function, and then the derivative of a rational function is a bigger rational function, a negative 1 over x to the minus 2. They don't keep repeating themselves. Okay, they don't get simpler, they get more complicated. Derivative of a tangent is a tangent secant. Yeah. Okay, now you've introduced something else. And derivative of an inverse sine is going to be 1 over the square root of, it's a mess. Okay, but the other functions, derivatives of constants are 0, basically. Derivatives of polynomials are simpler polynomials. Derivatives of exponentials are exponentials. Derivatives of sines and cosines are other sines and cosines. Yeah, the coefficients may get a little more complicated, and the signs change back and forth, but the thing is, they're still the same type deals. Okay, and that's why we use those forms. Okay, so here's the first example of this method. Okay, all right, I'm going to go to the whiteboard now, and I'm going to quit checking, since it wasn't a Zoom problem. It was evidently we just don't have any other students today. So let's go to the whiteboard. Hopefully they'll be watching the YouTube video. All right, that was the last problem we did, which should be sort of reminiscent if you take a look at this, except no, I think you started with pre-calculus trig, didn't you, Dawson? Yeah, so you didn't have pre-calculus algebra here, but hopefully in high school or somewhere you did rational zeros test, Descartes' rule of signs, upper lower bounds. I don't know if any of that's familiar. We did synthetic division, that's what we use, and then ultimately quadratic formula, which we have been using. So anyway, that's what you missed, but you can see it on YouTube video later, much later. All right, let's go to example 1 in section 4.4. Don't let me run over. This has been such a weird morning. Don't have a good grasp on time. Here is our problem. Solve this. Y double prime plus 4y prime minus 2y is equal to 2x squared minus 3x plus 6. Okay, now first step, do the homogeneous part. Okay, there we are. You do this part, y double prime plus 4y prime minus 2y is equal to 0. Okay, well, we just did things like this. Your assumption here is let y equal e to the mx. aggravates me when it does that. Go to right and it just changes to a select, and I don't know why it does it. It has to do with holding the pen on the screen too long, but sometimes it won't write unless, yeah, it's just a mess. This produces what we call an auxiliary equation. You remember what that is? M squared plus 4m minus 2 equals 0. All right. Do you have any clue that that may be solvable by factoring? Don't think so. So we go to the quadratic formula. Quadratic formula tells us that m is equal to minus b, which is minus 4, plus or minus the square root of b squared, which is 16, minus 4 times a times c, minus times minus is plus, 4 times 2 is 8. Okay, all over 2 times a, 2 times 1 is 2. All right, so this is equal to minus 4 plus or minus the square root of, I believe that's 24, right? Divided by 2, and I know that this is minus 4 plus or minus. I know that 24 has at least one perfect square in it, 4. It'd be 4 times 6. So the square root of 4 is 2. And the square root of 6 is just the square root of 6. Okay? Over 2. But this 2 will go into that 2 and also this 4 2 times. So your solution here for the auxiliary equation is minus 2 plus or minus root 6. Okay, that's your m. No i's are involved with this, so don't confuse it with your complex solution. This is just an irrational number. Okay, what does that tell you? That means your m1, let's call it that, m1 is equal to minus 2 plus root 6, and m2 is equal to minus 2 minus root 6. I don't know why the pen does that, but it does weird things. Okay, now, so your complementary solution is what we call it now. Y sub c is equal to c1. Don't get those c's confused. That stands for complementary. This is your arbitrary coefficient. c1 e to the minus 2 plus root 6 x plus c2 e to the minus 2 minus root 6 x. My phone's making a noise. Hold on just a minute. Let me see if it's anything important. It's somewhere local, but I'm in class. I'm not answering it. Okay. There's your complementary solution. Now we proceed to see if we can find a particular solution. Now, pure polynomial equations will produce a pretty simple, educated guess of what that particular solution needs to be. It sure doesn't need, it needs to be a polynomial, okay? No reason to throw in an exponent, no reason to throw in a sine or a cosine. It's going to be a polynomial. And your guess would then be y sub p, y sub p is equal to some arbitrary coefficient, okay, a x squared plus b x plus C. Now the pluses don't matter, the minus, yeah, just go and make them all plus, make it easier to work with. Now, if that's your guess of the particular solution, we need to find out what the first derivative of that is. y1 of p. What's that going to be? Can you tell me? (2ax plus b). And what's your second derivative? Y double prime? Y sub p double prime is just simply going to be 2a. So let's take those things, plug them back into the original equation, and see if we can make it work. Y double prime is 2a plus 4 times y p prime. That would be plus 8ax plus 4b. Okay, I have to pay attention to my writing here, because I was first thinking, is that an 8 or a b? That's a b. Okay, and then minus 2 times your y sub p, which would be minus 2a x squared minus 2b x minus 2c, and we say that has to equal to 2x squared minus 3x plus 6. If y sub p is a particular solution that gives that result, that's what we're saying. When you take the first and second derivatives of it, this is what it turns out to be. Let's see what we've got. Well, there's one and only one x squared term here, and that's this one. So that tells you that minus 2a has to equal 2. Well, that implies to me that a has to equal minus 1. Divide both sides by minus 2 and you got that. Okay? Now, the only terms with just a single x in it, negative 3 on this side, it's this term and that term. Okay? We already know what a is. It's a negative 1. So this says that negative 8 minus 2b has to equal negative 3. Because the x term here has to equal the x term there, right? Well, let's add 8 to both sides. Well, actually what I want to do is just make all those minuses plus. Minuses bug me, okay? Multiply by minus 1, okay. Then subtract 8 from both sides, and what you get is 2b is equal to negative 5. Wound up with a negative anyway, which means b is equal to negative 5/2. Okay, let me make sure I'm heading in the right direction before I go too far down the rabbit hole. Okay. Yep. B is negative 5/2. Got it. Okay. Now your constant terms. Where do I have room to write? Let me try it down here somewhere. The constant terms are 2a, a being negative 1, that would be a minus 2, plus 4b, but b is a negative 5/2, so that would be a minus 10. Okay. Minus 2c, that has to equal 6. Okay. Now, I think I'm going to do the same trick I did before. I don't like all these minus signs, so I'm going to make those pluses and make that a minus. Okay. This gives you a plus 12 here, which you subtract, and that gives you a 2c is equal to minus 18. When you subtract 12 from minus 6, That gives you C is equal to negative 9. Okay. Now, everything's fine and dandy except I have absolutely no place to write my answer. Okay, so let me get my answer written somewhere here. Okay, we've already used this. We've actually already used this and this and this and this and I don't want to lose all this, but let me lose as much as I can. I don't think I need any of this anymore. Oh, I probably needed that one, so let me hold off erasing that yet. And I definitely need what my A is, so let's leave that alone. Don't need this anymore. Come on. Why is the eraser stopped erasing? There we go. I definitely need to keep my complementary solution because that's part of the final solution. And I need to keep what B is. I think I could erase these parts. Didn't mean to erase the first part, but these parts could have been. This I don't need anymore. This I don't need anymore. That part I definitely need. That part I need. This part I don't need. This part I don't need. And C I need. Okay. So let's get my pen back. And let me write back in here. This would be oh yeah, I know what it was. That was a y is equal to ax squared plus bx plus c. That's y sub p. Okay, so here's our general solution then. Y is equal to your complementary part, C1 e to the minus 2 plus root 6 x plus C2 e to the minus 2 minus root 6 x plus, or actually minus, x squared, because the a was minus 1, minus 5/2 x minus 9. There's your solution. The general solution for this one. Notice all your arbitrary coefficients are in the complementary solution, the y sub c. All the coefficients in your particular solution are numbers. Not necessarily integers, but real numbers, no complex numbers. Let's see how the book did before I go too far here. Oh, there's the answer. Y is equal to C1 e to the, and they pulled out the minus sign in the second one, not in the first one, so they've got them in reverse order. Theirs was the C2 e to the minus 2 plus root 6 x plus C1, they do it reverse way, and they pull out e to the minus of 2 plus root 6 x. Same answer. Then a minus x squared minus 5/2 x minus 9. There's your solution. All right. Now, any questions on that? I think I will clear this because I'm coming back and going to be doing another one. But before we do the next one, let's just go back to our book, and I read it to you. Here's how they wrote it. There was a complementary solution. That's your first step always. Do the homogeneous part, make the g of x 0, do the complementary part, solution for the homogeneous part, and then guess what your particular solution is. Take your derivatives, plug those back into your differential equation, set that equal to the g of x, and then figure out what the coefficients have to be. And that's what they did here. They did it probably a little bit neater way than I did. It's supposed to be an identity, so the only x squared term here was minus 2a, has to be the only x squared term here, which is 2. That made a equal negative 1. The only x coefficients here, 8a minus 2b, has to equal negative 3. And when you plugged in the a was negative 1, that gave you your b of minus 5/2. And the constant over here was 2a plus 4b minus 2c, with a being minus 1, b being a negative 5/2. That now allowed you to solve for c, and you found and set that equal to 6, and that allowed you to find out c is equal to negative 9. So your particular solution was negative x squared minus 5/2 x minus 9. Put them together. General solution is the sum of the complementary plus particular. That would be c1e to the, and they put it this way, minus, they factored out the minus from what was my second one, their first one, 2 plus root 6x plus c2. I put this as a c1, e to the minus, they left that in the same form, minus 2 plus root 6x, and then add your particular solution, minus x squared minus 5/2 x minus 9. All right, here we go to example 2. Any questions on example 1? Okay, if not, here's example 2. Okay, this time they don't even ask you about the first part, okay, the complementary solution. All they say is find the particular solution, okay? So let's go with that, okay? Let's go back to our whiteboard. Okay, only got, wait a minute, we got 35 more minutes. Let me get something to drink. My throat is getting dry. As I said before, I didn't have my usual morning, so I don't think I consumed as much fluid as I normally do in the morning, so I'm running fairly dry right now. That's not enough. Wait just a second. Okay, here's example 2. All we're looking for is the particular solution. Y double prime minus y prime plus y is equal to 2 times the sine of 3x. Now again, all they're looking for is the particular solution. You could do the complementary solution. We've already done those like that several times, so let's just focus on the particular solution. Now, what's your guess? Y sub p, arbitrary coefficient, undetermined coefficient a, not arbitrary, undetermined coefficient a. We're going to determine it. Well, what you have to ask yourselves, what kind of functions will give you a sine with the function, its derivative, and its second derivative? Well, the function of sine will work, and the second derivative of sine is going to be another sine, okay? But the first derivative of sine is going to be a cosine. Well, you're going to have a cosine in there because the first derivative of cosine will be a sine, and you want sines. So basically you have two possibilities here. And it doesn't matter the order. I think the book usually leads off with cosine. I don't know why, but I'll just do it the same way the book does. A cosine, and guess what? You're not ever going to change that argument. So keep it as 3x. You don't throw in an x or a 2x or a 7x or a 6x or any other x. It's only going to need a 3x plus, another good guess, is b times the sine of 3x. Now, if that's your particular solution, you need to know what that first derivative of the particular solution will be, and that will be 3a minus 3a sine 3x. Chain rule, okay, derivative of cosine is minus sine, and then derivative of 3x is 3, plus 3b times the cosine of 3x. Derivative of sine is cosine, and then chain rule gave you the 3. What would be your second derivative of that particular solution? I don't know why the p didn't show up here, but it didn't. You need the second derivative as well. Well, that's going to be minus 9a sine 3x minus 9b sine. I said it backwards. This is cosine. Yuck. Get too focused on the wrong things here. Minus 9a cosine 3x minus 9b sine 3x. Okay. Now let's plug these values back into your original differential equation. So I'll come down here to do it where I have more room. Let's say minus 9a, I can't write, cosine 3x minus 9b sine 3x. That's your particular yp prime, double prime, minus yp prime, which would then be plus 3a sine 3x minus 3b cosine 3x. Goodness gracious. Oh man, my left knee gets really stiff when I sit too long, and I have now sat too long. Need to get up and walk around some, but let's finish this, okay? That's the minus y prime. Now we do the plus y, and the plus y would then simply be plus a cosine 3x plus b sine 3x. That's a 3 there. It doesn't look like it. Okay. And that's supposed to be equal to, all that is supposed to be equal to 2 sine 3x. Okay. So this time, rather than looking for power equalities, you look for sines and cosine equality. So the first thing you run into, you got cosines here, but no cosines here, right, on the right-hand side. So you know that all these coefficients for cosine have to add to be 0. So minus 9a plus 3a No, that's a sign. Minus 3b. Sorry. Minus 3b, the cosine terms. This one, and that one, plus a. Those are the three cosine terms. Those have to add to 0. So that basically gives you minus 8a minus 3b is equal to 0. Okay, now let's do the same thing with the sine terms. Minus 9b, let's do that over here. Minus 9b plus 3a, that's that one, plus b is equal to 2. What that gives you is 3a minus 8b is equal to 2. Now, let me make sure I haven't made a dumb mistake here. Minus 8a minus 3b is equal to 0, minus 3a minus 8b is equal to 2. Got it. All right. System of two equations, two unknowns. If you remember way back in algebra when you did systems of equations, this is fairly easy to solve by elimination by addition. But what you need to eliminate is multiply the top equation. I would choose to do it by 3 and multiply the bottom equation by 8. Okay? What that will give you, my nose is itching, we must be going to have company. I kind of hope so, because our main phone is out and AT&T is supposed to come and fix it, and they haven't shown up yet. That would be a minus 24a, that top equation. 24a, I said it and it didn't write. Minus 9b is equal to 0. I can multiply 0 by 3 and still get 0. Multiplying second equation by 8, you get positive 24a, which is exactly what I wanted it to be, minus 64a, which is a bit bigger than I was hoping. 64b is equal to 16. When you add these two together, they go out, and this gives you a minus 73b is equal to 16. So b is a nice round minus 16/73, one of my favorite numbers of all time. Okay, and that sure is what you got. Now, plugging that back into either one of these equations, and frankly, let's just go with the second one. Why not? That would be 3a minus 8 times a negative 16/73. Wow, I'm loving this one, is equal to 2. Now I know I'm going to wind up in 73rds, so let's call that 146/73. Isn't that the same as 2? All right, so let's multiply. 3a plus 48 128 over 73 is equal to 146 over 73. Okay, so 3a is equal to, if you subtract 128 from 146, I'm pretty sure you get 18, isn't it? That would be 18/73, and when you divide both sides by 3, you get 6/73. Okay, so what's the particular solution? I'll come up here and write it down. Y sub p, and that's all they're asking for here, is now equal to, goodness, my nose is itching like crazy. The A was, it's hard to read this writing, 6/73, I think. 6/73 times cosine 3x minus 16/73 times sine of 3x. I would be really tempted to factor out a 2/73. You don't have to do this, but it just seems like to me this would be easy to write. Make it a 2/73 times 3 cosine 3x minus 8 sine 3x. I doubt if the book does it. That's probably how I would write it. Let's see if we can find. No, they left it like we did, like we had it to begin with. 6/73 cosine 3x minus 16/73 sine 3x. That's your particular solution. Of course, that's not going to be your general solution. You'd have to do the homogeneous part, come up with a complementary solution, and add that to your particular solution. But notice there's no, in your particular solution, no arbitrary coefficients. Only your undetermined coefficients, which we have now determined. Okay. Now, let's just see how the other side did. All right, to clear this, or you like it kept a little longer? Okay, I'm going to clear. I can't hear any answer. And let's go back to still just the two of us. Your book here. And here's your solution. There was your problem. And yep, you get A is equal to 6/73, B is equal to negative 16/73. So the Y particular would be 6/73 cosine 3x minus 16/73 sine 3x. Okay. As mentioned, the form that we assume for the particular solution is an educated guess, but it's not a blind guess, okay? This educated guess must take into consideration not only the types of functions that make up g of x, but all, as we'll see in example 4, the functions that make up the complementary function y sub c. So we can't just throw out the y sub c, okay? So here is example 3. All right. How are we doing on time? I think we got time to do this one. All right. So let's go to our whiteboard. Now, I was hoping more people would be here, so what I say next, maybe take a time out to say this, because I don't want to get the whole class to go by without saying it. So I hope people are listening. Where are we and what are we doing from now on? Well, we're in chapter 4. We've done a fair amount in chapter 4. We got class on Tuesday and technically Thursday. Thursday's supposed to be final exam day. So what I'll be doing, we will have class on Thursday, but at some point we'll stop and I'll put the final exam out there now. And the final exam is just going to be the chapter 4 test. we'll stop and put out the Chapter 4 test, and the Chapter 4 test you will have Thursday, Friday, Saturday, and Sunday to do it. Okay? Now, usually I give you a week. We don't have a week now. So before I get any further, let me say this. I've received one and only one research paper out of this one of my best classes of all time. 1 out of 6 have turned in a research paper. Got to have those in, okay? Please try to get those in this weekend. Don't wait until next week. Get them in this weekend, okay? Your first test, I think 5 out of 6 have turned it in. And I wonder who the 6th person is. Dawson, we won't call any names, okay? The second test, I've only gotten, I think I got in another one. I believe I've gotten 3. So half of you have turned in the second test. Okay, now what does that mean? Please, folks, get your research paper, your first test, and your second test in sometime this weekend. Please get it done this weekend, especially that research paper, okay? Technically, Monday is the last day to turn that, Tuesday is the last day to turn it in. Please get it in by Tuesday. Sooner the better, okay? Because then on Thursday, I'll be giving you the Chapter 4 test, and you're only going to have 4 days to work on it, and I'd love you to get it done sooner than that. So I'll try to make it fairly simple so you can do it in that time. So please get that 4th test in to me, because I have to have grades in by Monday at, not this coming Monday, the following Monday at noon. Okay. Now, here's a little fly in the ointment with that, is that I am going to be out of town this weekend, and where we're going to be has really lousy internet, very slow and sometimes completely unreliable internet. So I will not be able to copy anything. So please get me the stuff in, so when I get back here on Monday, I will be able to start copying printing the stuff and getting it graded. Okay, so please get me as much as possible done now. Then when I do give you the test next weekend, next Thursday, 1 week from today, the Chapter 4 test, you have Thursday, Friday, Saturday, Sunday. Try to get it into me one of those 4 days. The earlier, the better, because I only have until noon to get your grades in on that following Monday. So try to get it into me by that Sunday evening. Earlier than Sunday evening if you possibly can. Friday would be wonderful. Saturday would be okay. Sunday all right too. Please don't wait until Monday. If you wait until Monday, you may wind up getting it incomplete until I can get everything graded. Because if everybody were to do that, no way I can get everything graded and in the system and get the grades in by noon. So I'd have to give a bunch of incompletes and then get my grading caught up and change the I's to grades. Please get it to me as soon as you can. Okay? That's my paid political announcement here. So let's move on to example 3. Now, I took way too much time there. Let's see if we can finish example 3. At least we'll get started on it. Okay? Y double prime minus 2y prime minus 3y is equal to 4x minus 5 plus 6x e to the 2x. Okay. I hope I copied it right. We may not finish this time because it's going to be a little more complicated, but where do we always begin? With the complementary solution. Now, if they just asked for what's a particular solution, we could have gone with that, but this one's not. Give the complete solution. So let's go with y double prime minus 2y prime minus 3y equals 0. Start with the homogeneous part. That will give you your complementary solution, and we always assume that y sub c will be e to the mx in some form of that. And that gives you your auxiliary equation to be m squared minus 2m minus 3 equal 0. Okay? That, folks, will factor. Thank you very much. M minus 3 times m plus 1. Hopefully you got your factoring skills down. Let's check it and see. M squared plus m minus 3m, that's plus minus 2m minus 3. Yep, that works. So that means that your m is either 3 or 1. Okay? So that gives your complementary solution to be y sub c is equal to c1, arbitrary coefficient c1, e to the 3x plus c2, I think I said minus 1, but the minus didn't show up, c2 e to the minus x. Okay, that's your complementary solution. Let's go fiddle with the solution on this side. Well, that's a polynomial. So I would guess your y sub p has got to at least have an ax plus, ax plus b. Okay? Now, to get a 6x e to the 2x as the first or second or whatever derivative, I'm also guessing this I'm going to have a c x e to the 2x. No reason to change the argument up there, but because when you take a derivative of that, you're going to wind up with a e to the 2x, I believe you're also going to have a term that's a plus d e to the 2x. Okay, just knowing, taking the derivative of cx e to the 2x, you're going to wind up with some term in there that's a c e to the 2x, right? So you're going to have a d e to the 2x to encounter that. So that's my guess of a particular solution. Okay? Now, here's something the book does that I don't do. They avoid the d's because they use d as an operator. So in the book, they make that an e to the 2x, which is a rather bizarre thing, but just to keep it the same way the book is, let me write that as an e, a capital E, not to be confused with the exponential e. So this is a capital E, e to the 2x. Now, what we have to do now is, of course, take your particular solution, first derivative of that, and that's simply going to be a plus, now we have a product rule, c, let's make that 2c, x e to the 2x, that's the first times derivative of the second, plus the second times derivative of the first, which would be a plus c e to the 2x. Yuck! C e to the 2x. I told you we were going to need that in there. Plus a 2e e to the 2x. There's your first derivative. Got it? Now, here's the question. Is it better to go on and simplify this? Perhaps it is. Okay, so let me simplify it just a little bit. A plus 2c x e to the 2x plus c plus 2e e to the x. Not going to make a lot of difference, but it might take a little. Okay, then you have your y sub p double prime, because you got to get it up here that way. So this is going to be, again, a product rule, 2c, well, make that 4. Come on, pen. The pen will not move. There it is. Okay. Okay. That's going to be a 4 c x e to the 2x. That's the first times the root of the second, plus the second times the root of the first will be a 2c e to the 2x. Okay, plus, and here you have just, and that was a 2x here. Yuck! This thing is so aggravating. That's a 2x there. It's an ugly 2, but it's a 2x. Okay, plus c plus 2e e to the 2x. All right, let's simplify that just a little bit. 4c x e to the 2x plus, now we have a 2c plus c, that would be a 3c plus 2e e to the 2x. Now, but folks, we have a problem. If you go to combine this complementary solution, I can't get my, there it is, this complementary solution with that solution here, oh wait, okay. Okay. I'm trying to decide which order we do things here. Okay. Okay. We're going to take this and solve for our constants first. I started to skip that part, but we can't. Okay. Now, let's write that down, the y double prime. This is going to take a lot of room here. Okay. So that's going to be 4c x e to the 2x plus 3c plus 2e e to the 2x minus 2 times y prime, so that's a minus 2a minus 4cx e to the 2x minus 2c plus, let's keep that a minus 2, minus 4e getting myself into trouble here. Maybe I should have left, yuck. Let's pull out the minus sign, so that will make that a plus. Okay, e to the 2x. Okay, that's 2 times the y prime, then minus 3 times the y particular, which is minus 3a minus 3b 38x minus 3b minus 3c x e to the 2x minus 3e e to the 2x. All that is supposed to equal 4x minus 5 plus 6x e to the 2x. Okay. Now, we have 2 minutes. And I don't think we're quite going to be able to solve this in 2 minutes. But let's just see where we are in our problem now. Okay. So we have a minus 3. Goodness gracious. They've recombined terms here. Okay. And they haven't done them in the same order I have. So I think where we're going to have to begin next time is at that particular solution. And I think that's just about where I did one earlier time as well. Okay, so sorry about this, but we'll be beginning basically right near the middle of the page there, y sub p, and we're going to have to redo some of this because they skipped a whole bunch of steps here, not a whole bunch, but some, to get what we need to do. So we'll start over there on Tuesday because we are 1 minute away from being out of time. So in order to keep from being completely out of time, let me give you some homework exercises. Okay, and this is a fairly long section. So I think you can do any of the odds 1 through 25. If you can't, stop, but do as many of those as you can. Any of the odds 1 through 25. And also get your research papers in. And also get your first test in. And also get your second test in. Okay? And we'll see you on Tuesday. Any questions? Any concerns? Any problems? Anything? Absolutely no response, so I take that to be none. So I think what I'll do is stop the sharing. I'm sick and tired of sharing. And unless you have any last thoughts or parting shots, I will end the meeting. So take care. We'll see you on Tuesday. Have a good weekend. Of course, working on differential equations will make it good. Okay. I need to find my screencast-o-matic. It's disappeared. I cannot see it anywhere here.